Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back, ready to wire up the output tubes on this little simple push-pull amp. And got all the ports here. Think we're ready to rock and roll. So let's get to wiring this thing up. So here we are at this point. I'm going to show you a few things that we covered in the other video real quickly. We've got a rectifier tube wired up. We've got this little strip here, which is where our B plus comes off this terminal at this end. This is our second cap. That's our first cap. We brought our heater wiring over here to these two terminals. And here we have our voltage divider for our center tap, where we raise the DC offset, which I'll explain when I go over the schematic why that was needed. So, got the tube sockets installed, and these are the two output tubes, and this is the driver tube, and I'll flip the amp over and go over why I put these tubes where I did. This is our AC switch, which you can see is far away from any kind of signal to worry about getting this AC noise into the amp, which is one of the reasons we laid the tubes out the way we did. So these Christmas colored red and green wires are our heater wiring, and as you can see, these are twisted up nice and tight, but not too tight. They're about a 45-degree angle to each other. Comes across, goes over into this corner of the amp, comes up to this tube, comes back down, goes around this corner, comes up to this tube, and then finally comes up and then goes across the bottom of the input phase splitter tube. And wanted to do it this way to keep it away from, this is the grid, which is going to come from the volume pot down to the grid. This is the tag strip for all the components for the driver tube phase splitter. Then we have a tag strip here and here for our output tubes, and this little tag strip here. We have our high voltage DC coming up to this tag, and then we're going to have the decoupling capacitor here with a dropping resistor, and then this voltage will be brought over here to the input phase splitter. The center of the output transformer comes over here to our B plus as well. These are our output transformer wires that we're going to be bringing over here to the output tubes. And one of the hardest things for me is to sit down and go over where these tag strips need to be and how many terminals I'm going to need for the components, and to make sure that we have enough lugs here to deal with wiring up all the various resistors and capacitors and stuff that the amp's going to need. And when I start wiring this stuff up, I'll do this in real time, kind of showing you where each component goes and how I determine to lay out these tag strips. You can also see that each one of these tag strips, even though they're bolted down to the chassis itself, the real ground is through these four wires that are going over here to our star ground point. And I know there's some people that say that these should be insulated from the chassis. I really haven't had any issue with bolting down these center ground terminals on the tag strips and then running a separate copper wire over here to the star ground point, because my theory is the ground is going to take the path of least resistance, which is this wire. The other little piece I'm going to show you, and I'm going to zoom in here for this. This is a small full wave rectifier that's going across the 6.3 volt AC, and then here's a filtering cap that's on the output. This is simply for powering up the light in our power switch. Like I said previously, the LED in the power switch is built into the switch, and I want to make sure that I send clean DC power to the LED that's in the power switch to ensure that it has a nice long life. And while I could probably put a diode just in one leg or something similar, I think it's worth spending a few bucks doing this little full wave bridge rectifier with a filtering cap to ensure that we don't have any flickering and that we're not putting undue strain on our power switch LED and end up having to replace the switch prematurely. Let me show you one other thing too. Over here we have our RCA jack, and then here is our little small volume control potentiometer that we're using in this amplifier. Because these are monoblocks, I just wanted a single channel potentiometer, and this will be in the BOM. This is a lot smaller than the ones that I normally use, and that gave me some extra room over in this little area of the amp to be able to put this tube where I wanted it. And the volume control, a normal double ganglia would stick out about that far and would start interfering with these tube pins. And so this little small one I think is going to work out great. Never used one before. We'll find out what it sounds like, and hopefully that's not going to be an issue. So let me flip the amp over and show you what the Topside looks like. So there's the tube layout I decided to go with. Again, this is our power transformer. Our rectifier is right here. Our choke's back here in this back corner. And so we've got all of the AC behind this line right here. We did run the power switch wiring along this upper corner up here to our power switch. And so I wanted to make sure that these tubes weren't near this AC power switch or the AC wiring. And so I offset this tube over. This is our input or phase splitter tube, and it's over here in this corner next to the volume control and the RCA jacks, like right here. And so that keeps the signal path really short, the low voltage part anyway, to this tube, and also keeps it away from any kind of AC current, so we don't have to worry about that. Then we've got this tube right here that's in the same plane, and then I offset this tube back so that the output tubes aren't in line with each other. I didn't really want to stick it up here and have these, hotter running output tubes too close to each other. I also looked at how I rotated these sockets so that the plates, because this is a beam output tube, so the plate is like this on this tube, and then it's like this on this tube, so that the plates aren't pointing at each other, which something I learned from working with a KT88 tube, and I thought I might as well apply it to this lower power amp as well. Let me rotate this around a little bit. So once I get the other mirror image built, we'll have the input tube here, the other input tube will be like way over here, and then we'll have like output tube, output tube, output tube, output tube. It'll make kind of like a little V shape with the output tubes, and I thought that would look good. And it still leaves some room right here to put a meter or maybe some potentiometers for adjusting the fixed bias if we decide to go that route, which is something I would like to experiment with. And you can see I got my cool little decorative trim rings that are threaded so that they act as the hardware for holding the tube socket sandwiched to the top of the chassis. And as you can see, there's no hardware holding anything down that's visible, except in the back we have these two little acorn nuts that are holding the choke, which I think look kind of cool. So, and they're centered with the rectifier tube. So I think it's going to look pretty cool. Also went ahead and I actually had some Allen bolts here that I'd forgot I've got, so I painted these little washers black and then put some black hardware in the transformers, and I just think that looks so much better than the silver ones with the little white washers that these transformers come as. The other thing that I did, since I got the heaters all wired up, is I went ahead and powered the amp up and checked the heater voltage to make sure that all the heaters are powered up, that they're all glowing, we don't have any shorts or anything, because as you can see, this heater wiring is going to be underneath all this other wiring, and if we got a problem with the heaters, we want to find it out now and not after we get the whole amp wired up. So highly recommend that you power the amp up in stages as you're building it, so that if there is a problem, you're not looking at a finished amplifier trying to figure out what's going on, and you can catch any mistakes as you're going along. So the next thing that I want to do is I want to hook all these wires up to the output tubes, and then hook up the cathode resistor and capacitor and get everything on both these output tubes wired up, and then power the amp up. And at that point, we'll have enough load on our power supply to be able to see what our B plus voltage is going to be and see if it is where we want it or not. And hopefully it will be. And then once all of that's working, we can do the final step of wiring up the input tube and the phase splitter, running the coupling caps over to these output tubes, and then throw it on the bench and start testing to see what kind of output we get out of this thing. So let's jump in that next. Okay, so we're ready to wire up one of the output tubes, and I've decided how I'm going to lay this tag strip out. I want to make this where the grid or the signal comes from the phase splitter, so it's as close as possible to that tube. And we're going to do that on both these tag strips. So I'm going to make this one the plate. So we're going to put a little jumper wire in here, and we'll solder that in place, and then hook the lead from the output transformer here. This is the screen, and the schematic shows putting a 100 ohm resistor between the output transformer and this pin. My experience, I usually run about a 1.2K resistor on the screen, but I'm going to go ahead and put a 100 ohm one in here like the schematic shows, and then measure the voltage of the screen versus the plate, and we may change that later, but for now we're just going to put the 100 ohm one in here. And so I'm going to come in here and put like that, and then we want the resistor down close to the pin and like down low on the pin too, because these are like slotted. So we're going to put that like that, then trim that off and solder it over here. And then the screen from the output transformer will hook up right here. The next thing will be to put a jumper wire between this terminal and the cathode, and then the cathode resistor is going to sit like right here. And I'm going to try something a little different in this amp too. I'm going to scrape the powder coating off underneath this resistor, and I've ordered some adhesive thermal pads to mount this to the chassis. And my goal is to not have to drill holes and have hardware showing through. And the thermal pad that I bought got a lot of good reviews, and I think if I use some fairly stiff wire, solid core to go between here and here, and then from here up to this ground, it'll help hold it in place on that thermal pad, and then the heat will get transferred to the chassis and dissipate out the top of the amp. The other component that we have to mount is going to be this bypass capacitor, and this is a audio note, one of their just general type, not the fancy ones, but still wanted to use a nice bypass capacitor, and it's going to go between this lead and this lead. I'll bend these up and get them how I want them, and then probably have it sitting vertically like something like this, maybe even like on this side, to get it away from this resistor and the heat that it puts out as much as possible. And since the heat's going to be rising, put this below it. It'll help keep this away from the heat being generated by that resistor. And then the last thing we'll do is we will put the grid stopper resistor between this terminal and here, and then the grid leak resistor will go from this terminal over to the ground, and then we can put the coupling capacitor between this terminal and over here to where the phase splitter is when we get to that point. So let's solder some of this up. Bring over our output transformer lead. And come in and solder this one together. Here's our ultralinear tap, or screen tap as some people call it. I've seen people get almost upset over calling this an ultralinear tap. They're claiming some specific manufacturer, it was a branding for their exact circuit, and unless it's their exact circuit with their branded transformers, it's not really an ultralinear, which I personally think is kind of silly, but some people get pretty passionate about some of these things, so it's not something I'm going to get into a big debate with anybody about. But I think given what the design did was take a percentage of center tap off of the output transformer and put it to the screen. I think it's fine to call it either one. And one of the things I've run into, you can see the problem happening here. Let me turn this around where you can see it better. Because I've got the amp where this tag strip is vertically, this hole in the lug doesn't want to fill in, and you can see the solders being pulled by gravity down low, away out of this hole and away from these terminals and these wires. So a lot of times when I have this issue happening, I'll stand the amp on its back so that this is parallel to the ground, and it makes it a lot easier to fill this hole in and make sure you get a really good connection between these components and this solder lug. You can see on this one that it filled in fine and I was able to get it to cooperate, but sometimes gravity starts fighting me, so I'm going to stand it up on its end and get this solder joint the way I want it. And you can see now, after I stood it up on its end, that big blob of solder that was down here flowed out and filled up the hole, and we got a nice solid joint there now. Trim off this excess. And I intentionally just kind of poked this through the hole and soldered it to make it easier to swap this resistor out if I determine I need to put higher value in there to get the screen voltage where I want to see it. So let me go ahead and put this ground wire from here over to here. So we know about how long we want to make it. Go ahead and cut this off. And it is nice having a variety of wire colors so you can kind of keep track of which wires are going to what, and knowing that this isn't a power, that this is the cathode and it's going to a ground. Having a black wire helps me just kind of keep track of what each of the wires are as I'm working on the amp. So here's that little guy, and we actually need to cut this a little shorter, but that's okay. We can always, it's better to have it just a little bit too long than it is to cut it too short and not have enough there to work with. Wrap it around the lug really well, so we know this isn't going to change. And so, kind of go like this. We can, we'll come in here and bend that over. Zoom in here and show you what that looks like. So get that bent over. We got that one bent over. We're ready to solder the socket into that one in. And then the next thing that we want to do is probably go ahead and solder in the resistor that's going to jump across here. And we're going to put some insulated tubing on this guy to make sure that we have a good, safe connection across there. So it's going to go across like that. And I want to have this resistor as close to this pin as I can, but still have enough lead to get over to this terminal. So let me get a little PTFE tubing and put it over that bare lead so that we have some protection from a short. And this tubing I use, it's sold as tubing to be used on 3D printers, but it works really well for doing electrical work like this. It looks nice. It's pretty temperature resistant as far as melting while you're trying to solder around it. I'll see if I can kind of prop it up with these pliers while I'm soldering it to hold it in place, or hold it kind of where I want it, like that. And I've heard arguments both ways about that these need to be close to the pin, like I've put this. And I just feel like that unless there's a good reason to not have it close to the pin, it makes sense to mount them as close as you can, like I just did. So then I'm going to bend this little guy up. So let's go ahead and we'll tack that up at the top. And there we go. Then the other thing, we've got these, these wires running at like 90 degrees to each other. And I mean, if you wanted it to look nicer or more even, you could like make this one the plate, make that one the screen, and then you could run the grid straight over to here, and then have the capacitor go, across here. But I felt it was better to keep the signal path as short as possible from the phase splitter over to the output tube. So that's why I crossed them over like this. But you can do it however you want. If you think it, would look neater, it probably wouldn't have a huge impact. I just Also keeping the coupling capacitor away from these output transformer leads is probably a good idea. So let me make up the wiring to connect our resistor and our bypass cap, and then put in our grid leak resistor, and we'll be done wiring up this output tube. Well, that's it for this segment. I try to keep them around 25 to 30 minutes, and so we're going to cut it here, come back in a few days, and finish wiring up these output tubes, and get this thing on the variac here, and pull it up, see what our voltages are, and see what this little thing is doing. Feel like we're going along pretty smoothly right now, and let's just hope everything continues. Hope you're enjoying this series. If you are, please consider subscribing. Please like the video, and we'll see you soon. Have a great day.